So yeah, today we're going to learn Python. It is probably without a doubt the most popular language in the world. Most popular programming language, for sure. It's what everybody learns first. At a lot of places, we don't teach it first in our own classes here. If you take CSCI 40, we teach C++ instead, and the reason for that is it's a long one. But it's like what Fresno State wants to see. But a lot of schools, especially like UCs, where you have 3 classes a year that you could take things, 3 quarters, they start everybody with Python. Okay, so I'm going to teach you Python today, and it's going to be great. All right, you'll see that it's very similar to Scratch. It's very similar, but slightly different. All right, Python is a language that you can't really use on a website. I guess there are websites that let you have Python programs and it'll run it for you, but honestly, we want to install the language itself. All right, so if you go to python.org/downloads, or you just search Google for Python download. And I can't even spell download. Let me delete that. Download. It'll just take you to this page, download Python, python.org, and you want to download this one. It shouldn't even give you the option for Python version 2, but we want 3.12.6 apparently. And it knows that I'm on Windows. You just save the installer file, and then you open that installer file. And in theory, you should be able to click install now, and everybody's happy. All right? Just click the button, and in theory, everybody can get this working and will be happy. Okay? In a pinch, there are websites that you can be like, Python online. You can search for that. But I would rather you guys get set up this way, because that's the way that I'll show you how to do stuff. Go to this website, install Python on the machine in front of you, and let me know if it doesn't work. So I'm worried now. My laptop is obviously significantly slower than these giant gaming PCs. It's making its way there. So just hold on for mine. And then once it installs, ironically, you do not want to search the start menu for Python. That is not the program you want to open. All right, it'll show you like, oh, I just installed all these things. Don't search it for Python. Well, actually, it does it right because of what I've done before. But if you click Python 3.12, that takes you into a black screen with tiny text. That is not actually what we want today, all right, or ever. Instead, the program we want to open after we install it is called idle. All right, we want to open it. It's called idle. All right. So search your start menu for idle, and then Python in parentheses. That's what we want to open. And this is Python in a sense. So the first thing I want to say, I guess, is Python. Sure, its mascot is 2 snakes, but honestly, it was named after the Monty Python comedy group, if you guys have watched those movies or heard of them before. So you'll see a lot of references to that in the documentation, and then idle is the last name of one of the characters, or one of the people in the comedy troupe. All right. So yeah, that's Python in a nutshell. But yeah, get that installed and open up idle, the program called idle, please. All right. So everybody been able to find that. Does it make enough sense for now? So this is a nice window where we can write things. All right. So that's Python. Yeah. Yeah, I'll show you in just a second. So it's a little weird. What you get plopped into when you open up idle is not like a file where you can write code. It's like a Scratch window. It's called the REPL. All right. It's called the REPL, and that stands for, it's an acronym, stands for the read, evaluate, print loop. All right. So when you type code and you hit enter, it will read that code, evaluate it to get an answer, and then print out that answer, and then it's ready for the next line. So you can type individual lines of Python code, and it will do it for you. So if I type 2 + 2, that is valid Python, and I hit enter, it will read what I just typed, evaluate it to 4, print the 4, there it is, and then give me another prompt so that I can have another piece of Python code. All right, so math is technically Python code. All right. So yeah, that's the REPL. Eventually, we're going to like go to file, new file. We're going to like make an entire program, but you can type individual lines of code just there. All right, and so yeah, let's kind of talk about first what in the world is Python. So it is a programming language, just like Scratch, of course, but it is not graphical at all. All right, so instead of hooking blocks together with your mouse, you are going to type lines of code. All right, so like thing 1, thing 2 becomes in Python line 1, like that thought that corresponded to that block in Scratch will have a line in Python that you would just type out. All right, it's text now, and then line 2 would come after that, and it would run them in order still because the line 1 was above line 2 in the actual file. So that's a thing. So your code isn't blocks anymore; it's just lines of text. You're writing text. It's like an essay, in a sense. And so yeah, if you want things to happen right after each other, like in Scratch, you put them right after each other. You do the same thing, just put the 2 lines right after each other in Python. All right. It's gonna get a little weird because eventually I need to show you like the equivalent of like the if then else, right? Block where you can like shove things up into there, and like how do you do that in Python? It's gonna have to do with indentation. We'll get there, but yeah, in Python, every time you write a valid line of Python code, it means something special, and it will go off and do whatever it meant, all right, whenever you run that code, all right? Though, unlike Scratch, Scratch is very helpful for beginner programmers like us, but in Python, you can mess up. You can have typos in Python very easily, right? You can misspell stuff, and so in Scratch, it was impossible because they gave you the blocks themselves. In Python, you have a whole new class of errors. You can speak it wrong, and it will just give up. It will just tell you, nope, I don't know what you're talking about. I'm going to stop the program. That's a new kind of issue that we'll notice soon enough, all right? And so Python will complain if you ever make an error. And the thing that's running the Python code, it's like reading your text. And it's like, you think of it as like a translator. It's interpreting it. It's the Python interpreter. That's the full name. So yeah, let me just show you some simple things that we can type in the REPL, some simple lines of code, simple operations. All right? So math is technically Python code. All right? You can get plus, like I showed you. You can naturally get minus. Star is for multiplication. So 2 minus 2, 4 times 2. There, star for that. Slash for division. I don't know. 3 over 2 is 1.5. Sure. And then the percent sign, which I've shown you before, that gives you the remainder. Remember that one from converting to binary? So that is called the modulus operator. But I'll pronounce it in the verb form. I'll say modulo. So yeah, remember that if you do x percent sign y, that means it's almost like a normal slash for division, but it's got some circles, right? X percent sign y means give me back the remainder, right? Give me back the remainder after dividing x by y. Okay, so like, I don't know, 42 modulo 2, 42 mod 2 is going to give me back the remainder. It's going to do the division. It'll be like, all right, it goes in what, 21 times? And with nothing left over, it'll give me that nothing back, all right? 0 left over because it's even. If I did 41 mod 2, that does not go in cleanly. When you divide by 2, there's always going to be 1 left over. All right, so that's the modulus operator. If you want powers, you get 2 stars. You use 2 stars, not this character, right? Which is kind of how it is on most calculators. Not that character. That does something completely different. 2 stars gives you power. So like 2 to the 5th power. Cool, right? That's the idea. So that's valid math. You can type it in the REPL. It will read that code. If you wait it to an answer, and it's looping around. It's ready for the next one. Any questions about that so far? Is that okay? Math is Python. You technically know a lot of Python because you know math operators. All right. A new thing that we need to worry about now, that Scratch has been taking care of for us as well, is the types of things. All right. So types are important in Python. Right? Python knows what the types of things are, by the way. All right. You can say, well, let me explain them first. So I want you to think of a type as like a cloud where you can put stuff, right? And you can only put certain kinds of things in that cloud, all right? So there's a type called int in Python, and things that can be ints are only whole numbers, all right? So like 0 is an int, 42 is an int, 1 is an int. They can be negative as well, like negative 42, that's an int, right? Short for integer, of course. And that is technically a type. And you can always, Python knows, you can ask it, hey, what's the type of something, by typing out this type, and then parentheses, and between parentheses you put the thing you want to know the type of, and it'll tell you. It's like, all right, what is the type, Python, of 42? It's an int. See that? That's an int. But only whole numbers are ints. 42.5, that's something different, right? That's called a float. So if you want numbers with decimals in them, even 0.0, the possibility of having decimals, that's called the float type. So everything that's a float lives in the float cloud, all right? So that is like, I don't know, 20.0 is technically a float because you have the 0.0, right? 3.14, that's a float. You can have negative values, 23.145, I don't know. So that's a float type, right? It's different from int. Not the same. So even 42.0, technically a float, right? So that's the idea, all right? There's one more important type to start us off with. It's called str. Str is short for string. Remember that I was telling you about that in Scratchland. It's just anything that you can like interpret as text. Stuff between quotes is a str in Python, right? So the strs look like this. It's anything that goes in between quotes, either single or double quotes. Python doesn't care. So I can say double quotes hello. That's a str. Single quotes hello as well. That's a str. And then notice, quotes 42 is a str, it's not a number, all right? Let me show that to you. So like, I don't know, A, B, C, D, it evaluates to itself, of course, but you can ask its type. What is the type of hello between quotes? It's a str, it's a string of characters. And then you could use single quotes as well, doesn't matter. It's a str still. And notice that, this, right? Completely different, even colors it differently. The type of that is still a str, it's not actual numbers, all right? Because it's between quotes. And the whole point of having types is you can do different things differently, right? Or you can do the same things differently in Python, right? Because plus and times, those work on numbers, of course, like 42 plus 2, that's a thing. And same with times, 42 times 2. Those work in int land and float land too. But they also work in string land and str land. Watch. String 42 plus string 42. It makes a bigger string by just tacking the characters together, right? Hello plus hi. It makes a bigger string by just tacking the characters right after each other. Do you see how that's not doing math, right? It's still doing a plus idea, though. And so that's why types are very important. We have to keep them in our minds, right? Multiplication also works on strs. 42 times 5 is just repeating that string 4 times, giving you back a new string, right? Any questions about that? That's why types are important. We have to worry about them now. All right. All right. So with that in mind, let's see, what can I show you? Yes. Do you know how to start attendance? I thought I did. Did I forget? Oh no, I did. Yeah, please do attendance. All right. So with that, let me give you like the screenshot of all these bad boys. Things that you could do. Right here, let me give you a bigger screenshot. That includes all this. Now I have a question for you. All right. Take a minute to try this. Here's my question for you. I'd like you to create this string, right? Hello, space, hello, space, hello, space. A bunch of hellos, 42 times with a space in between. Yeah. So that's 42 hellos. I'd like you to compute that large string for me, please. But spaces in between, except for right there at the end. There is no space after that, all right? So that's going to be a little tricky. There's not a space right there, all right? Can you figure out how you might make that work? All right, how can you build up that string? All right, so give that a try. You don't have to type it anywhere. Just like try it on your own. In a couple minutes, we'll come back. We'll see if we all got it. All right, for those of us who just came in, I need to show you how to download Python. You can also go to that website if you want to, but I'd rather you get the actual program today. So you know how to do it. You install that one. Once it's installed, you'll open up there's no space in there. It's like the easy way, right? I'm showing you. You can use parentheses if you ever need to. Like that, that'll work. Not that one. Go back to the start menu. Search for ID. Give you another minute to think about it. It's a little tricky. My hint to you is multiplication is important, but also you'll need to use the plus. All right. Everybody get it? Did you learn the secrets? So let's simplify this first of all. If you need a hint, how could we just do 3 hellos, right? 3 hellos in a space at the end. I couldn't say this, right? I couldn't just like repeat this 3 times because that would be hello space, hello space, hello space, right? It'd still be a space at the end of the third one. We don't want that. So these though, like there is a repetition going on here. I can do it twice. I can do that hello space twice. But this last one, this last hello, does not have a space at the end, and so it's kind of separate and different. Does that make sense? So I can do this first, and then just tack that on at the end with the plus. Does that make sense? That's going to be the secret. All right. So let's do the 3-1 first. If I just do hello, single or double quotes, doesn't matter. Hello space times 2, right? That gives me that one with the space still. If I want one more, copy and paste it back. I think the order of operations will work just fine here. Yeah, there it is. Does that make sense? And you could have used parentheses if you wanted to. If that helps you think. That's totally a thing. But yeah, to get 42 then, I would like 41 hello spaces, right? And then just one normal one at the end there. And there it is, 42 hellos without a space after the last one. Does that make sense? Any questions about that? This is non-trivial. All right. So yeah, that's Python. That's the start of it at least. Let's talk about fancier things now. All right. Printing, getting variables, using variables, getting input from the user, all those kinds of things that we've been doing in Scratch, of course. So let's figure out how to do these in Python. All right. So we need to get out of the REPL first of all. This is a nice place where you can do like some quick math if you want, but it's not really a good place to write a program. We never want to write our programs in the REPL. Okay. Never, ever, ever. So Instead, what we're going to do is we're going to break, we're not going to break, we're going to make a brand new file, all right? We're going to make a brand new file and put a bunch of code in that file, all right? So that's what we're going to do. And so in that file, we can put a bunch of code, right? A bunch of lines of code, and they'll run one after the other, all right? That's what we're about to do. And those lines are called statements in Python. Our programs are going to have a bunch of statements in them, okay? And the standard extension, like you give a name, like program or whatever, the standard file extension for Python programs is .py. That's what I'm going to do right now. I'm going to make a blank file that we will fill up with Python statements, right? The way that you do that is through the REPL. You say File, New File, or Control-N. And this gives me a blank place, a little blank slate, where I can type multiple lines. So like, say multiple lines, and they don't run when I type Enter. It's just a blank slate. And Python will run all of them for me when I go to the Run menu, right? So let me save this in a place so that you can have it later. Or I'll do it in a second. But yeah, that's what we're about to do. We're going to make a brand new file. And yeah, every line that we put in the file will run one after the other. That's the order of it all, which makes sense. And yeah, I think the most important first program that I should write for you, of course, is a Hello World program, right? I need to make a program that prints Hello World to the screen, because that's what you're supposed to do every time you learn a new language. So yeah, the way that you do that, because the REPL was kind of printing for us, right? P is in its name. So if you have just a program, you want to run some lines, you don't want to print everything always. You want to print stuff sometimes. And so you can control that with what's called the print function, all right? So it's very similar to how we asked Python to check the type for us with some parentheses. It looks like this, right? If you want to print something to the screen from a file, from a normal Python program file, this is what you say. You say print, it's the name of a function, it's meant to do something, and then in between parentheses, you give whatever you want printed out. If we want to print hello, we'll give the string hello, all right? That's what we're going to put in our program. But yeah, this is an example of a call to a function, all right? So print is something that the Python people made for us. It's like we don't have to do it ourselves, which is nice. Whenever we call this function, it will print whatever we put between the parentheses onto the screen, out into the screen, all right? And here's kind of what a function call looks like. Here's how they all are going to look, right? You first say the name of the function, all right? So print is the name of the function. It's that extra special code that somebody made for us. So print is the name of the function. And then the things between your parentheses are called arguments. It's like the metaphor is you're yelling at the function. You're calling to it, hey, print, do something for me. And it's like you're arguing at it. Do this with your printing, all right? Print that exactly for me, all right? So these things that you put between parentheses are called arguments. Some functions take multiple arguments, like they need two things to work on. So you just comma separate all the things that it needs. Print can just as easily take one thing as it could take two. Like maybe you want to print two things. But we just want to print one string, so you give that one string to print, and that is called an argument. So there's one argument to this call to the print function. Right? I know these are a lot of new terms for us, but I'll say them enough that you'll get used to them. One argument to the print function. I guess. All right. So, yeah, sometimes functions, they don't just go off and do something like print to the screen. They might give an answer back, and you might want to save that answer away using this equality thing that I'll talk about soon. That's going to put it into a variable, all right? So, yeah, just for print, though, we're going to make a single program file that says print. All right, we're going to call the print function. Did it, but if you're still in the REPL, you'll go to File, New File, all right? And this will give you a blank slate to write Python code. I'm going to say print, and then some open parentheses, and I'll say hello, comma, space, world, exclamation point, all right? Between either double quotes or single quotes. Python does not care. Your strings can be either one, all right? And so I'm going to save this somewhere. You can save it wherever you'd like. Save it in your downloads folder or whatever. I'm going to make a new folder for us so that we have it, so I can give it to you later after class, just like I've given you all the other stuff. Where is my desktop? There it is. So today is lecture number something. I'm going to go figure that out real quick, because I always make that folder. So it's lecture 13 apparently today. So I'll make a brand new folder. for lecture 13, but again, you can save yours wherever you want. And I'll call it Hello World. And it's kind of small to see, but by default, it'll put the .py at the end for me. So I can just say the name and it'll put the .py for me. So this is saved a file named helloworld.py, all right? And you can have multiple lines in this file, multiple print calls, that's fine. I'll just have this one line, and to run this program, this is a normal program, this is where we write all our programs in Python, not on the REPL. You say run module, right, or F5. And there it is. It went and it ran that program for me. It went and ran every line in the file, there's only one though, and it printed hello world to the screen. Do you see that? Isn't that beautiful? So run module again, it'll rerun the program there. You see it being printed out there. So that's our first Python program, okay? If there were multiple lines, it would run them in order. Okay. Any questions about that so far? Did we get it? Get it working? All right. So usually, like you're going to have longer programs, of course. Let me show you how to document your own program so you can remember when you wake up tomorrow what you were doing. To make comments in Python, you can use number signs to make a single line comment, or if you have a multi-line comment, you can use triple quotes. So let me show that to you. All right. So number sign. The second I put a number sign, it changes everything. It changes the color. So this is called a comment. This is how comments work in Python. This is a comment. Just that number sign marks as everything after this number sign is not real Python code. It's just a comment. All right. It's not Python code. It won't get run. If you have multiple lines of comments, though, you have to, if you're using the number sign, you have to redo the number sign. It only works for that line. Everything after the number sign is a comment, and you can have the comments appear on lines after code too, like print hello world. Like what does that do? Document it. This prints hello world if you really wanted to. Okay, it's just the second this starts, it marks a comment. Everything after it is not looked at by Python. It's just for us, the programmers. Right? And the code will still run. It'll run just fine. This is the only real line of Python code still. Right? If you want to type a big long essay of documentation, it's kind of unfortunate that you would have to put a number sign at the start and remember to do that. If you want a multi-line comment where you don't have to keep putting a number sign, the way that those work is you can use triple quotes, either 3 single quotes or 3 double quotes, and this will be the marking of a multi-line comment. And you see it's still green, right? Multi-line comment, and it's still going, all right? Until you're done with it. You have to mark the end of your multi-line comment with another matching 3 triple quotes. All right. So again, it's not actual code. It's secretly just a string, actually, but it's not doing anything. It's just marking stuff. It's a comment. All right. So this is still the only line of real code in here. Python is ignoring everything else. Okay. So yeah, those are single-line comments and multi-line comments. Does that make enough sense? So again, everything is text, so we have to have a textual way of marking what our comments are and what is actual Python code. Okay, so those are those. Yeah, let's learn how to make variables now. I think we're ready for that. So, okay, if you would like a variable in Python, you can give it pretty much any name you want within reason. All right. The one thing you can't put and use as a variable name, this is why I did it in Scratch, even though Scratch allowed it. You can't have spaces or special characters like exclamation points or things in your variable names. Okay. So your variables in Python, they have to start with either an underscore or an alphabetic character, lowercase or capital. And then after that, you can use those still for your further characters in the name of the thing. And then also you can use digits too. So the names of variables in Python, they can't start with a number. All right? So like valid variable names would be x, underscore, underscore, x, underscore, 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 blah, 42, valid variable name. But 42 blah, not a valid variable name in Python. Okay, can't use spaces either. Okay, and if you would like to put something into a variable, the way that you do it is you give it a value with what's called an assignment statement. All right, an assignment statement looks like this. You say the name of the variable that you'd like to give a value, then you put an equals sign, and then you give something on the right side that is either a number, like a value immediately, or something that will eventually become a value, like 2 plus 2. Okay. So kind of what happens is it runs all this code over here, gets it as a final answer, and it shoves whatever that final answer was into the variable. Okay, So like this line, if I said x equals 42, that line, it's essentially like you kind of treat the equals as an arrow. The information's going that way. This is already a value, and so it's just going to make a variable x if it didn't already exist, and make it hold 42. Okay, does that make sense? That's how we can make a variable in Python. And because of the way this works, like this gets run before this line works. What do you think this line does? Because this line gets run first, right? This side of it, right? This side of this right-hand side gets executed first. So it all makes sense still. If x holds 42 right now, this will go off and it will compute 43 and shove 43 back into x. There is no ambiguity. It's very weird though. Not the mathematical kind of equals. I'd rather you think of this as like an arrow, okay, rather than equals sign, because it's not. You can change variable size. All right, so let me show that to you. Let me make a new file that has stuff about variables. So I'll go File, New File. I'll save it just at the start. I'll call it vars.py, so you'll have it later. And let me make some variables, at least one. Right? So x equals 42. So now x has a value. And now I'll have a second line that does something. So next thing that I want to have happen is like, let's print the value of x. All right, I'll save the file, run it. So it just prints 42, obviously. But we're using x, and we're getting back what it held. All right. And then if I want to change it, x equals x plus 1, I can do that. It'll take the 42 that's already in x, make it 43, it'll see that, and then it has the answer to shove back into x. So now if I print x right after that, you'll see that this program will now print 42, then 43. Does that make sense how I'm reading that? Only the print lines are actually shown in the output, because that's what it means. Like, I want you to print something now, please. Okay. These other lines are just doing stuff with the variables. Okay. We go with that. So that's how you're going to use variables and update them in Python. I think the last big piece of the puzzle for the day is like, let's ask the user for stuff, because like it's kind of boring to have programs that run the same all the time. Let's ask the user for something, and we can do stuff with whatever they give us. Let's learn how to get input from the user. All right. So the way that you do this in Python is not the print function. There's another function called input. All right. So functions are going to be the name of the game in Python. That's just where the people that made it will give you stuff that you can use. Okay. So it's called input. And here's what input looks like. Here's how you use input. You say input, of course, say its name, and you always give parentheses, and you can put another thing within parentheses, just like we did for print, and the argument that you give to input is going to be the prompt that's shown to the user as they're typing their input, right? So usually it's going to be a string, of course. You'll make it a string, and it'll show that whenever it'll stop the program and then ask the user for something, and then this is what it shows them, like enter your name or something. And I'll show it to them on that line. So I like to put like a colon and then a space to end my string, because it'll let the users type right after that space. It kind of looks clean, right? And then what input does is it stops the program, shows the prompt to the user, lets them type. The user will hit enter when they're done typing, and then input gets whatever they type back, all right? It gets whatever you typed back, and it results, this whole big thing, it results in whatever the user gave you. You can pretend that it's being replaced with whatever the user gave you, and you can shove the answer that it gives you back into a variable, like resp for response, I don't know. But it gives you back a result that is the user's response as a string of characters always, all right? Even if the user types their favorite number instead of their name, you're getting it back as a stir. All right, that's a huge, huge issue that we will deal with later. All right, so it's always a string. Remember that for now. That will be important, and we'll learn how to convert them. All right, so but if the user actually does this right, like this will make a variable, resp, and input saw, whatever the user typed, it will give that back to you, and it will set resp to the string that is whatever they type. So maybe I type my name. Okay, let's make that program now. So again, I'll go to File, New File, I'll make a brand new program. You guys could just be using the same file if you wanted to. Doesn't matter. But I'll make a new file called getting inputs. So I'll say input, and then say, hey user, enter your name. and I'll give a colon space to end my string with, because it'll look very cute and nice when it works out. And then this whole input function will give back, it will result in whatever the user typed once they're done typing, and I can shove that answer into a variable. I'll call it resp for response, like I was doing. And so whatever we get back is always a stir. All right, let me show that to you. So let's print the type of whatever we get back in resp. I'm going to run this program. So I'm doing that. So print whatever the type of resp is. You can chain those function calls. And we'll print whatever this results in. So enter your name, Lawton. It is a stir. And if I rerun this program and pretend that my name is 42, this is very important, it is the stir 42. It's not the number 42. It does not work with math just yet. Okay? That's very, very important. So let's take that answer that the user gave us and let's greet them now that we got their name. Okay? So this will be different every time depending on what the user types. So let's, I don't know, let's say hi. Hi, Lawton, or hi, whatever your name is. Okay? So how do you do that? I like to print whatever, I like to say hi, right? Hi, comma, space. And then whatever your name was, which we stored in the resp variable, plus resp, see that? Plus, I don't know, exclamation point. You see how that will build up the string? Hi, comma, space, exclamation point. And then it will print that, if that's what we typed in as our input. Once you type enter, it will get it, and it says, hi, Lawton. Cool. If I pretend that I am my cat, his name is Lonzo, it says, hi, Lonzo. It's different every time, depending on what you typed. You got your input. That's pretty nice. Any questions about that? All right. Print, by the way, it can take multiple arguments, and it will just print each of those things with a space to separate them. So another way to do this would be all right, print hi, comma, without a space, because once I give multiple arguments to print, it will introduce the space for me. Hi, comma, resp, and then I want to print hi, comma, I want to print resp, and then I want to print exclamation point. All right, so this is multiple arguments to print. That's the thing. So print can do that. I want to show you that right now. Actually, let me show you that later. Forget I said. We'll come back to it. All right. Let's instead talk about the numbers thing. I think that's more important. But yeah, so if I type 42, it says hi 42, which all works out. But if I wanted to do math with that 42, we have an issue. Okay. So let's ask the user for their favorite number. Let's be like input. Enter your favorite number. And then we're going to notice, right? We can shove that into a variable, whatever we get back. Notice that, let's print out the type of num. It's going to be a stir, all right? And maybe I want to print whatever their favorite num was times 2. Let's see that there's going to be an issue here. All right, so enter your name, Lawton, favorite number 42. It was a stir. And so 42, the stir times 2 is 4242, just the characters, right? Has no knowledge of numberness. That's a bit of a problem. Okay, so num right now, it's not 42, it is the string 42, okay, if that makes sense. That's the main difference right now. So if you want to do math with what the user gives you, you have to convert the types. We don't want to stir. We don't want to be living up in the stir cloud anymore, even though that's what we always get from input. We want to convert it to either a float or to an int, okay? And the way that you do that is you pretend that the name of that type that you want it to become is like a function. Give it the thing you got, like num or resp, and you can call into a function, and this will translate it. If it was actually a number, it will translate it into the int form, into the float form, all right? So that's going to be the secret. That's what we need to do here. So instead of this, we're not ready for this yet. A nice thing to do in Python is you don't like this line, but you want it to be around still. You can, this is called commenting out a line. All right, so now this line is a comment. It's not actual code anymore. So I put a number sign there. It's not going to run because we know it's incorrect. Okay, so I can convert num, the stir, to an int by saying int num. All right, calling the type that I want it to be like a function. And this will give me back that thing as a number. It won't convert it and change num. It will give me back a new copy of that integer form of it. And I can shove that into maybe a new variable, num as int. Okay? And so num, remember, num is only a stir. We must convert it to an int. Okay, so that's why we got to do that. And now, using that variable, that does have the normal 42 because we're doing that conversion. And so now I can say num as int times 2, and I get what I really wanted, the actual mathematical multiplication by 2. So there's my 84, right? Because I did that conversion, and now I'm happy, right? If you think that the user might give you their favorite number with decimals, like their favorite number is pi or something, you'll have to convert it to a float, because ints can only be whole numbers. All right, so I think that's a good example. Any questions about that? So this is a good one to study for sure. It's a good example of variables, getting inputs, type conversions. It's a good one for sure. All right, if we're good, I should show you that printing stuff. So print can take as many arguments as you want to give it, and those things go between commas, right? You comma separate all the arguments that you're yelling at your function to work with. So when you give multiple arguments to print, it prints them all out with a space in between each, okay? So if you wanted, kind of similar to hi comma space, your name, you could have said this. 3 separate arguments to print. Hi comma space, comma, print resp2, comma, print also an exclamation point. And it will print out all these things on the same line, and they will be, space separated. And so there is like a unfortunate space before the exclamation point, but like that is technically correct in certain languages. Like in French, that's what you do. You put a space between your exclamation point. So that would work if we were writing French, but not quite English. And so if you want to control your spaces, you got to like do the plus and like just create one big string to print out like we were doing before. Okay, if you want finer grain control. But yeah, that's what you can do with print. It will eventually make it work. All right. Any questions about any of that? It's like the basics of Python. Are we good for fancier concepts? Because I want to show you some more functions that have been made by the nice Python people. All right. So I want to teach you how to do fancy math in Python. And so the makers of Python have packaged together a lot of mathematical functions and ideas into what's called the math library. There's a bunch of different kinds of libraries in Python. That's a common term across programming languages. And what a library means is like you're going to a library and you're checking out not books, but code in our case. All right. So a library is just a bunch of pre-written code that was made by somebody else so that you don't have to reinvent the wheel. And you can use it as much as you want. So a library is just a bunch of pre-written code that you can use inside your programs. So we're going to include the math library in our programs now. And so there's a nice documentation page that tells you exactly all the things that exist in this math library in Python. And an easy way to get there is just to search Python math. That'll take you to the first thing will be the math documentation for the math library. Right? If you scroll down, you'll see that there's a bunch of them. A bunch of cool things that you can do. Greatest common divisor of a bunch of numbers. What are some other ones that we understand right now? E to the power of something. Give me the log base E, natural log base 2, log base 10. Raise something to potentially a fractional power. Square root of a number. Sine, cosine, tangent. All those fun things. They exist in the math library, which is kind of where you expect them to be. Right? So let's use this. Let's use this math library to do cool stuff. Right? So if we would like to use the magical functions made for us in the math library, we have to what's called import the library. We have to say to Python, hey, I know you have a math library. I want to check it out at the library right now. I want to use it. Okay. So this is what we're going to say at the top of our program. We're going to say a line that says import math. That tells Python, I would like to use the math library, please. All right. And so what that does, once you say that, anywhere below that line, you get to use math library stuff. It has checked out the book for you. All right? Makes math library functions available to use. And there might be like a competing math library that you downloaded on your end and you also import that. So to keep things straight, you have to always, once you're using something out of the library, you have to say the name of it and then a dot. So if I want to use, it doesn't have to be just functions in the library. There are variables too in the math library, like math.pi. That's the pi variable, which gives you pi, of course. So you always prefix it with the name of the library and a dot. All right. Like if you want the square root function, it's math.sqrt. Sine function, math.sine. All right. So it's always the name of the library that you're importing, library name, dot, thing inside library that you would like to use right now. All right. So that's, you have to qualify. Which one do I want right now? It's part of the math library, not like the secret math 2 library or something. Okay. So let me make a file that shows you some math library stuff, and let's see, I'll just show you a bunch of things. And so I'm going to make a new file, and I'll save that file with a name. The one thing you cannot do once you're using libraries, though, I cannot save this file and call it math.py. Okay? I'm not allowed to. The secret that I don't really want to tell you too much about right now. Like never, like all caps. This will mess you up, all right? Never make a file with the same name as a library that you're using in that file. So never call your file that uses the math library math.py, because what this line really does is it goes looking for a secret file called math.py somewhere in wherever you installed Python. If you made your own file math.py, then it notices that one takes precedence, and it forgot about where the real math library lived, okay? So that's why you can never make a file with the same name as the library. That's a very common error that I see. Okay, so I'm going to save this as something other than math.py. I'll call it math stuff. That's fine. Okay. So I'll say at the start, I would like access to the math library, please. So I'll say import math. Import math. And now we're allowed to use all that stuff. All the math library. Okay. And so, I don't know, what's a good example? Do I want to do that later? No, this is a good time, I think. So let me throw a math problem at us. Let's say that we would like to, let's calculate the area of a circle with a radius 4.5. All right, so if that's the radius of our circle, how do you compute the area, right? It's pi r squared, yeah? So we're going to have to multiply pi by the radius squared. All right, so let's do that. And I can use variables for this. Like, okay, the radius of my circle, like make it easy on myself. Like this is very helpful. Radius is 4.5, just make a variable called radius. And then, all right, the area that I'm trying to compute, that is, well, there's a pi in the math library, a very good approximation of pi. It's right there. There's also e and some other things. But here is as good of pi as we can have, possibly. Math.pi is a float, not just 3.14. It's as accurate as it could be. And so I like to use the math library's pi variable. So math.pi, pi r squared, so it's pi times the radius squared, and radius is just in this variable. I can say its name, radius squared, and we all know that exponentiation happens before multiplication, so that like the order of operations works in Python. But just to spell it out, this is unnecessary, but we could use parentheses too. So that's our area, right? And so after these two lines have been completed, we have successfully figured out the area of that circle, and we can print it out. All right. So this is super helpful, especially even if you're not going to be a programmer one day, like just to break out Python and like separate everything into variable names. It's very easy to do like longer ideas. All right, and apparently this is as accurate as we can get the answer to be, but that's going to be our area of that circle. Okay, so it's using the math library for just a variable. There are also functions in the library, right? So let's talk about some of them. You got the square root function, the sine function, and plenty more. So let me show you that. Let's, for my next example, let's calculate calculate the square root, SQRT in Python land, of just like a number that the user gives us. So it'll be different every time. that the user types. All right, that'll be fun. So let's ask the user for a number. We'll say, all right, input, enter a number, and I like to give a colon space so that like there's some space after the prompt for them to start typing. I'll put that into the num variable, and as we all know, whatever they typed, it was like 3.14. We're getting it back as a stir. It's just a bunch of characters, 3.14. It's not a number yet, so we have to convert its type. Right? So the user might type a number that has decimals in it, so let's convert it to a float. Float num, please. And I'll shove that in a new variable called like num as float. Okay, that could work. And then I like to take the square root of that number and print it out. All right, so let's do the square root first. That's math.sqrt, and it takes one argument, the one thing that you like to compute the square root of. So num as float. There it is. And so this will compute the answer. And what do we want to do with it? Do we want to put it in a variable? Do we want to print it? We would like to print it. All right, that's what we like to see. I'd like to see this answer, please. The square root of the number that the user typed. So you can chain these calls again. It's going to do the inner ones first. Like, okay, take num as float. You kind of read it outwards. Take num as float. Take its square root, whatever that is, print it. That's kind of how you read that. Okay, that's the secret there. Yeah, so let me show that to you. Number 42, and then this is apparently the square root of 42. All right, and it's different every time. Enter number 2. There's the square root of 2. Enter number 3.14. It gets it, and it calculates the square root of it. Isn't that beautiful? We don't have to like program the square root. That would be very difficult. All right. Yeah. Does that make enough sense? We're just using these library functions. And you can always scroll through the documentation and see what's there. So there was the square root. It took one thing, and it gave you that thing back. All right? So let me show you, like, let's do one of the trigonometric functions to end it on. Let's be like, let's calculate the sign of that number. So math.sign is another thing. It's always math dot, whatever you want. Let's do the sign of that number. Math.sign of whatever that number was. The float version, though, of course. We can only do math on numbers. And we can get that and call it like sign of num or whatever. We can call it a variable, that's fine. And let's print out the sign of whatever the number gave us, or whatever number the user gave us, in a pretty way. Let's not just like be like print sign of num. We're better than that now. All right, so let's say like, okay, the sign of, and then we'll give num, right, num as float. These are multiple arguments to print. It'll just space separate them. This is perfect. The sign of num as float is, right, print out all these things, please, for me, Python. Print this string and then a space. Print this string and then a space. Space is to separate. Print this string and then this one. All space separate is perfect. All right, so that'll be a very pretty answer now. Enter a number. The sign of what? Pi, maybe? Pi over 2. I don't know, man. 3.14. That's 0. Cool. So yeah, the sign of pi is, if it's the y, yeah, that's the 0. And it's accurate to 2 decimal places because that's what I gave pi as. Perfect. Yay. Does that make sense? And it printed it out in a very pretty way. We had the old value, num is float still. We had the new sign of that we saved into a variable. And like in a very nice, clean way, we printed out the answer. And this is kind of like how we would like our programs to look. Like that's very helpful for somebody who wanted that. Yeah. Cool. So yeah, that's a good example of library functions. Are there any questions about that? All right. So I would like you to try this. I'll give you all this code. If you have not typed it out yourself yet, it'll be a little small, so you have to come up to the screen. But here's my question to you. All right. Dun, dun, dun. Here's all this. I'd like you to write a program that gets 2 numbers from the user. All right. 2 numbers from the user. Call them A and B. And I'd like you to compute the square root of a squared plus b squared. All right. So all those things I've been doing, I did it in this file. All those pieces. I'd like you to make it happen. All right. Because like, you're essentially making a program that solves for the hypotenuse of a triangle, aren't you? Of a right triangle. Please, like, A may have been 3 and B may have been 4, and your job is to compute the hypotenuse square root of 3 squared plus 4 squared, which is 5. Okay? That's kind of your game right now. So take two numbers from the user, get them both, two separate variables. Remember to convert them, right, to potentially floats, I guess, would probably be the best one because you could potentially get a number with decimals, not just ints. So floats. And then compute the square root of those numbers squared. A squared plus b squared, and then take that square root and print that out. Okay? So using what I've given you, so you can get that working. And please ask questions. Like, I'll be here to help as you try it. I think this is a great, great test to see how much you're understanding. And just like do it on your own. You don't have to put it somewhere. Yeah, I'll give you like a 4-minute head start. Plenty of time. Please let me know if it's stuck. Eventually use programs. Just open up like a Facebook. Yeah, I'm very happy that I didn't know if you do graphical steps until very recently. Oh, to get the numbers, that's this, right? These two ideas. Ask the user, convert it to a float. That's like for A and for B. And then here's how you square things. There's how you square things. And then pretty much put all that together somehow. A couple more minutes to try yourself. Yell at me if you're stuck at all. I want to get you unstuck. I'd rather you do it than I do it and show you how first. You learn better when you do it yourself. I think I still accidentally left the attendance running, so make sure to do that within the next 30 seconds. No. Oh, that's startled me. Alright. So yeah, Are there any questions that came up as you tried this? Did we get it most of the way? Get it all the way? All right. So yeah, you're going to get all this code. Remember, if you've never looked at the code that I've given you before, in every programming lecture, let me just prove that to you. In every programming lecture, there's a link at the bottom to the code. And so there'll be one there too for today, eventually, once I upload it all. And there's also this link, Code from Class, which I have technically forced you to look at by now. The only way that the week 1 module will open is you looked at this page once. Remember it, okay? That's where everything's going. So, yeah, let's do it. Let me show you how I might think about it. So I want 2 numbers from the user, and then I'll make a new file for this. I'll call it, what do I want to call it? Like hypotenuse, because it's really solving for the hypotenuse of a right triangle. Hypotenuse.py. And so I want 2 numbers from the user. Import math, of course. Need that math library. I want 2 numbers from user A and B. There they are. Just like that. Let's make this smaller. So I need to get A and get B. So I need to be like, hey, input, enter A, colon space. And we'll get that back as like A, right? Though I would like it to be a float, like A as float. That's kind of what I did in class, right? As the example. It's like the floating point version of it. That's like the technical term. So convert it to a number, an actual number with decimals, please. And then I start using this variable if I wanted to. That's kind of how I did it before. But let me show you a trick. You can do it faster. Let me get rid of that. It's like, all right, whatever I get back as input, whatever that was, convert it to a float, please. And show that float now in A. You see that? Like, give me this input. We'll do that first. Give me the float version of it. Do the type conversion. And then show that in A, please. That's quicker. Okay? That's better. And then we'll do the same for B. And that will give us 2 numbers. And we only needed 2 lines to do it. That's not bad. All right? So I like chaining function calls when it makes sense. And then we would like to take A squared and B squared. Like the A star star 2, B star star 2, right? Add them together. And then we want to take the square root of whatever that was. Okay, so that's going to be your math.sqrt, that one. Okay? So math.sqrt of whatever that was, that's my answer. That's my hypotenuse. And then, like, that's what I like to print out, too. Like, after I've spent so much time computing that thing, that's the answer that I want to show the user, that they waited so hard, or they worked so hard on, right? They were waiting so long for. So, yeah, those are the lines. Enter A if it's 3 or 3.0, 4 or 4.0. That is one of your special triangles, right? 3, 4, 5. I forget what the other one is, right? What's the other? I guess you have multiples of that. You also have like the 1, 1, root 2. It's been too long, but it's working. And that's the idea. Any questions about that? That's how I would think about it. All right. If we are happy, I'll probably just save this one for you to try on your own. I think I would like you to, like, after class, if you can. There should be plenty of time, but I want to show you one thing first. Like, try to make a program that just does something cool that, like, does your math homework. I don't know. Try and make something that's useful to you given what you know so far. I think that's a great way to practice Python. I'll let you try that on your own. Right? Before I stop the lecture, at least, and just give you a chance to play around, I want to show you one very, very important website that will just save your life as you're writing Python in this class. It's called Python Tutor. You can search through it on Google. It's just called pythontutor.com there. Just like Python Tutor. What it does is it shows you, and you click Python, or I should have clicked Visualize Code. There it is. So there it is. And you can copy and paste your program into here, and it will show you how it works. Like if you're confused about why your program's doing something weird, it will show you every line, what that line's effect was on your program. It's really, really cool. All right. So let me show that to you with one of these files. What's a good one? Maybe this one. It's like x and x plus 1 line. The one caveat of this program, of this website, is once you click this button, it's going to try and like show you step by step each line how that works. the one thing this thing can't do is get input. So if you ever get input from the user, you have to kind of hard code it to be something else. So like, I don't know. Let's actually do this one anyway, for fun. Like you have to hard code it. Like A, we're not getting input anymore. It won't work like that. Just like hard code it as 3. Hard code B as 4. Something like that. Okay? That's kind of the idea, and that's how that works. Okay? Let me mess it up a little bit. Let's be like B equals B times 2 or something. I don't know. So this is a program. Let me make it a little bit bigger for us to see. And you can click Visualize Execution. You got to get rid of all of the inputs, right? Because it doesn't know what happens. But once you've done that, it'll take you to this page. And you see your code on the left and some stuff on the right that will eventually happen. And it shows you that we're on this line. It'll walk you through all of your code, and you get to see the effect of every single line, and you can find your error that way. Right? I promise it's going to save your life one day. The first line doesn't really do anything. It's like, okay, I have math available to me now. These words may eventually make sense. And it's like, okay, this line, what does it do? It makes a variable called A that holds 3. Next. There it is. Isn't that very, very helpful? You get to see its values change too. B is 4. There it is. It made the variable. B equals B times 2. If we forgot what that did, we can take it to here and be like, okay, next. What does that do? 8. See how it changed? Previous, next. Previous, next. That's beautiful, right? We get to see exactly the values of our variables right there. And then we could have split this up into multiple lines, but we're just doing it. Hypotenuse equals that. It computed the answer. It's like, okay, there it is. And then the last line, print hypotenuse variable. Next. And like here's a pretend output window. All of your print things would appear here. Okay? And so if there was an error and you're not sure why, take it to here, hard code all of the inputs, take it to here, and step through it and find the line that was doing something weird that didn't match what you thought it should do. See how that's going to save your life one day. Really, really good website to have. Okay? So that's called Python Tutor. And I believe that is all that I wanted to show you for the day. I think highly recommend just trying out Python, taking the stuff that I gave you today. I'll upload the code soon and just like try to make something cool happen with it. I think that's a great way to practice all this. It is kind of new, okay? But I believe that is all that I wanted to say for the day about Python. And I don't think there's any new assignments, but let me confirm that. Yeah, so it's just the lecture for the day. And so yeah, that's all I got.